Hi, welcome to Applied Python Cryptography by Code Red EC Council. My name is Christopher O'Mara and I'm the instructor for this course. Let's take a look at the roadmap ahead. This course contains 7 sections that will walk you through cryptography concepts such as symmetric cryptography, hashing, asymmetric cryptography, and steganography. By the end of this course, you will not only have a better understanding of cryptographic concepts, their history, and their modern use, but be able to apply them in Python. In Section 1, we will go through the history of cryptography from its origins millennia ago, as well as its use in the modern age. In Section 2, we will walk through the installation of Python and our integrated development environment Visual Studio Code, then set up our project, followed by a Python refresher. In Section 3, I will introduce you to the concept of symmetric cryptography, and live coding exercises will be included to cover the Caesar cipher, the Vigenère cipher, the Data Encryption Standard or DES, and the Advanced Encryption Standard or AES. In Section 4, I will introduce you to the concept of hashing algorithms, and live coding exercises will be included to cover password hashing, rainbow tables, salting and peppering, and data integrity and checksums. In Section 5, I will introduce you to the concept of asymmetric cryptography, and once again, live coding exercises will be included to cover the Diffie-Hellman key exchange, Rives-Shamir-Edelman or RSA, message authentication codes or MACs and digital signatures, as well as elliptic curve cryptography. In Section 6, I will introduce you to the concepts of steganography and obfuscation, and we'll have a look at image-based steganography in Python. Finally, in Section 7, we'll take a look back at what we have learned and highlight the key takeaways. Then, I'll say my farewells. There are a couple prerequisites that will be required for this course. For the hardware requirements, I'll first state the recommended, then the minimum. For the operating systems, recommended is Windows 10, Mac OS X 13, or Linux version 8. The minimum will be Windows 7, Mac OS X 10.11, and Linux versions 6 or 7. The recommended processor is Intel Core i7 or equivalent, with the minimum being Intel Core i5 or equivalent. Recommended memory is 8 GB of RAM, with the minimum being 4 GB. Recommended storage space is 256 GB, with the minimum being 15 GB. For software requirements, the operating system would be the previously mentioned Windows, Mac, and Linux versions, but you also need Python version 3.11.1, and for the developer environment, we're going to be using Visual Studio Code for this course, and you can just grab the latest version of that. Most sections in this course will be accompanied by a live coding exercise, and a link to the GitHub repo containing this code will be made available, though I do recommend that you follow along and join me in writing the code. This is just an introduction to the concepts of cryptography and how they can be applied in Python, so to keep things succinct, not everything will be covered. I would also encourage you to take these concepts and try and integrate it into your own test applications. And with that, let's begin. I'll see you over in Section 1.